Welcome to another segment of high school geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are covering 3.3 Triangle Congruence Criterion. What we are doing? Well, by the end of the lesson, you will understand one of the most important applications of geometry, proving that shapes and figures are congruent. This is a large part of our course, and you will see it repeat itself over and over again as we move toward the end of the semester. Why we have to know this? Well, understanding the congruence of triangles allows us to draw conclusions about the congruence of all polygons. How you will know you know it? I'll know I mastered it when, given two congruent triangles, I can show the interior angles and sides are congruent.
All right, let's go ahead and get started. So the first thing we're going to talk about is what is triangle congruence. If you remember from last chapter, congruence is when you have two shapes that are the same shape and same size. So triangles are congruent if and only if all three corresponding sides are congruent and all three corresponding angles are congruent. So if you look at that, you'll notice that we have 6 total parts that we are working with. We have 3 corresponding side lengths and we have 3 corresponding angle measures. That is a total of 6 pieces. What we're going to be doing today through discovery is that we have shortcuts. There are certain shortcuts we can use where we're only using 3 parts rather than needing to know that all 6 are congruent in order to establish that the triangles themselves are congruent. Some vocabulary words. You are going to hear us talk about the word included, and you will need to know what included means in reference to those shortcuts that I just was talking about. Included is when something is between or trapped. I like that when you wrote that word. So included is when you have, for an included angle, it's when 2 sides meet at the same vertex. So you can go ahead and draw this triangle, CAT, and I'm going to talk about included angle C. C is the vertex that is right between side AC and side CT. So you can see even through just the names, vertex C or angle C, notice that that letter is part of both side names. That is going to be an included angle. It's when it's in between the 2 sides you're using.
You could almost think of it as the 2 segments are both kind of pointing at or
it's where
attaching
they intersect
to.
at. It's where they meet up at.
It's the vertex of those 2 segments.
An included side is going to mean the same thing, only using the opposite pieces. So an included side is when 2 angles share a same side. So I'm going to go, notice I have the same picture. Go ahead and draw another triangle, CAT. If you need to pause the video, go ahead. I'm going to talk about the bottom, side AT. If I look, side AT, the end points of AT are vertex A and vertex T. So therefore, we can say that side AT is included between angles A and angle T. Okay, so what we're going to be doing today, you can...
I kind of put this off in the margin.
You're going to write this down the side, the left side, kind of turn your paper long ways and write it down just as an important piece. So one of the struggles with today's lesson is the shortcuts and knowing how to identify the criteria for each shortcut. Similar to naming a polygon where you go around the polygon clockwise or counterclockwise, where you're naming the vertices, you're going to be using sides and angles to see if you have the right criteria or the right information to use a specific shortcut.
So think of it as you're going clockwise or counterclockwise, naming the parts of a triangle. So we've got here this picture for you.
So if you're using this side, this angle, this side, you would read that as side, angle, side as you go around the triangle. If you are using this side, it depends on what you know is congruent. If you're using the sides, you would read those parts around clockwise or counterclockwise, side, side, side. If you know this angle's congruent, and this side, you would go around it clockwise or counterclockwise and see that you have 2 angles together. So this would be an angle, angle, and side.
Yep.
So that's just again, just a helpful hint for when we go to the other side of our notes. The way you're going to be establishing the criteria is the congruent pieces. Again, you're going to need to know 3 parts are congruent. It can be any combination of sides or angles. You will read the congruent parts around clockwise or counterclockwise. It doesn't matter which. And if it's one of the criteria that is accepted, then that would be the reason why we can say the triangles are congruent.
Again, the trickiest part of this lesson is just knowing how to name it. And the best thing to do whenever you're doing triangle congruency criterion is always mark what you have.
It is required by both of us that you mark your diagrams.
And then once you mark what you have, ignore everything else and just look at what you have.
What you have that's congruent.
And that's your criterion.
Okay, at the bottom of this side of notes, I put a line right down the center at the bottom underneath important pieces. We're going to talk about reflexive property again, and we're going to talk about vertical angles again. So underneath important, always look for, go ahead and maybe put split it in half vertically. On the left side, we're going to talk about reflexive property. So reflexive property first appeared in our chapter 1. It's going to show up a lot in this chapter. You're going to see it a ton because you're going to have triangles that are joined together. As you can see, triangle LVE has a segment inside of it, forming 2 triangles. So you have 2 triangles pushed together, sharing that side OE. This is reflexive property. This is how you are going to use it mostly in this class. We would say that OE is congruent to itself. So side OE in this triangle LOE and OE in triangle VOE is congruent to itself. Why? Because of reflexive property. Just a little side note, just so you guys know, if you ever see this, this is a shorthand for the word because. 3 little dots where there's 2 on top, 1 on bottom, that means because.
Or it can also mean therefore. So
Therefore actually goes this way.
Oh, you're right.
There's shorthand for therefore.
So if you think about it like this, if you look at the triangle LVE, the big triangle, that big triangle shares that middle piece. It's almost like it's 2 smaller triangles that have been cut in half, and like Siamese twins kind of. They both share that same centerpiece. That thing that they share is your reflexive property. It has to match on both of them if they both have it.
It's a shared part. Angles can also be used in reflexive property. You're not going to see it as often, but it is possible to have 2 triangles sharing an angle.
Sort of like if you've got a big triangle and then a smaller triangle that's set down into one of the angles.
You'll see that more later on in this class. All right, and then I also said at the bottom, on the other half of the bottom for important pieces to look for, are vertical angles. Vertical angles, you're going to see 2 triangles drawn like this. You know that your vertical angles are congruent because vertical angles are congruent. That's why we say it. I call these my bow tie problems. They're always going to look like a bow tie. The 2 triangles are together by forming like a bow tie.
And they know vertical because we've
had this again.
Yes.
This first appeared in section 1.2, I believe. Remember, with vertical angles, you do have 4 angles using that vertex. You have, because you have 4 angles sharing the same vertex, notice that I did not name them by angle A. You're not going to have angle A is congruent to angle A because that would be reflexive property, which this is definitely not a shared space. These are 2 separate spaces.
In addition to that, if you call it angle A, there's 4 angles there. I really wouldn't know what you're talking about anyway.
All right, go ahead and turn your paper over. We're going to talk about the criteria that are accepted. There are 4 that are accepted that you're going to learn today in this lesson. The first is side, side, side. So if you have congruent sides of 2 triangles, you can say that the whole triangle is congruent. So in this case, you can see we're going to write this on your guided notes right above the word triangle congruence. You have a long line. You can go ahead and write side, side, side. And then maybe along the left side going down, the abbreviation is SSS. So most often you can write it out as side, 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 but you can also and will see it abbreviated as SSS. I went ahead and also gave you two triangles. I have the letters for the vertices ONE and LUV. If we are going to use this criteria, then you would have something like this, where you know side ON is congruent to side LV. You would need to know that NE is congruent to UV, and you would lastly need to know that OE is congruent to LV. If you know this information, then you are able to say that the triangles are congruent. You would be able to write a congruency statement for the triangles. And the reason, the because, is side, side, side. That's the why, the theorem, the why we can say that this is true. And once you know that, you would now know that the angles are all congruent because the triangles are congruent, therefore their sizes are congruent. The next one that is accepted, we're going to go to the right, top right. This is side angle side.
And this is where the whole included thing is going to come in that we were talking about earlier with an included angle. So if you think about side angle side,
notice that the angle, the A, is right between the two sides in the name. So therefore, it is implied that the angle must be included between the two sides. So you have to have two congruent sides and a congruent included angle. So if I were to, I just picked sides to use here. I have the same diagram as I had for side, side, side. If I am using angle N, then ON and NE would have to be my two congruent sides. Angle U, then LU and UV would have to be my congruent sides. That is showing that I have an included angle. N is included between side NO and side NE, and UL is angle L is included between UL and UV, as you can see.
So it's almost like the angle has been trapped or caught between the two sides.
There you go. All right, moving to your middle row, the first one is going to be angle side angle. So with angle side angle, the name is telling you exactly what you need. And going back to the vocabulary word from the other side, the side, based on where the word side appears in this criteria, or the S appears in ASA, it is implied that the side must be included between the two angles that you are saying are congruent.
So the side is what is trapped between the two angles.
So here's just an example. I have the same diagram. If I were using angle N as congruent and angle E as congruent, well, the included side would be NE. So NE would need to be the congruent side. You can see, as I was saying with that margin note that you made, if you were to read this, I'm not going to leave this on the screen, but if I read this around, well, here's an angle. Oops, why did that not work? Here's an angle, here's a side, and here's an angle. So you can see if I read around this in pieces, you have angle, side, angle right down the right side of your triangle.
And if you need to do that on any of your diagrams just to help
I know
you
that
keep
helps
it
a lot
together,
of students writing.
you can absolutely do that.
The last, probably the most complicated, is angle, angle, side. And the reason this one's a little bit more complicated is because the side, now notice it is not included. The S comes at the end. And that doesn't mean it has to be on the right side. It doesn't really matter where it goes. The reason why this is more difficult, we're using the same amount of angles and the same amount of sides. If it's not the included side, that means that there are two other sides it could be. So it's really important that you're looking at corresponding parts when looking at this. So again, I'm going to use the same diagram. I'm going to use actually the same angles that we used before. Angle N is congruent to angle U, and angle E is congruent to angle V. So you can see that NE and UV from the previous picture were the included sides. Because my side is now not included, it would have to be one of the other two sides, which leaves me with these two. It could be either of these two. Those are the two not included sides. Now, it has to be corresponding. So you can see I have OE. Well, what's corresponding to OE? It would be LV. We would not have OE congruent to LU because those are not corresponding to each other. So if you were to read this around the diagram like I mentioned before, well, here's an angle and an angle. The side does not fall between them. Side angle angle is one that pops up a lot. If you had side angle angle, I would not mark that wrong. It means the same thing as angle angle side. You will just not see it written officially that way. It's always going to go angles first. Not sure why, probably alphabetical.
Probably.
So those are your 4 congruency criteria that you're going to be learning in this lesson. It is important to know that the ones that you are not allowed to use that do appear quite often when trying to prove triangle congruency. The first one is side-side angle. Side-side angle is very often written on papers. If you look, I have 2 triangles drawn here. I hope it is blatantly obvious that they are not congruent. They are not the same size triangles. However, if I were to translate this triangle over, notice that I do have a pair of congruent angles. This angle right here is congruent. So if I slide this back, those 2 angles are congruent. I would also like you to notice that the bottom is congruent. Why that happened. Notice that the 2 bottoms are exactly the same. And then the last piece that I want to show you, and here's the kicker, if I were to rotate this around and then translate it, notice that this side is actually also congruent. So what this triangle is showing me is that I have a pair of congruent angles. I also have a not included congruent side. And yet the triangles are obviously not congruent. So side-side angle is not one that you are going to want to use ever. And this is the proof why. Here's our angle. Here's our side, and here's our side. That is not the same triangle as this triangle, even though the parts are all the same. Over here, for angle, 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 if I take this smaller triangle, you could see same angle, same angle, same angle. All 3 angles are congruent. So we have 1, we have 2, and then lastly we have 3 right here. These triangles are definitely not the same size though. So angle, angle, angle is another time when triangles are not going to necessarily be congruent. Could you have them be congruent? Yes, but it does not guarantee congruency.
To help understand angle, angle, angle and why it doesn't work, I often will tell my students, if you think about a triangle that is equilateral, where all 3 sides are the same and all 3 angles are the same, could you have a very small equilateral triangle? Well, of course, all 3 sides are the same, all 3 angles are the same. We know each angle is going to be 60 degrees. But if we were to stretch that triangle to be very large, we'll say as large as a 10-story building, well, all 3 sides are still the same, not the same as they were on the smaller triangle, but the angles are all still 60, 60, 60. So angles match, sides don't. You can also think of this with a square. We can draw squares in any number of different sizes. Regardless of how large the square is or how small the square is, all of the angles are still 90 degrees.
So that is going to be the conclusion of our lesson. So please, the big pieces of information here, know your reasons why they're the same and notice why they are different. Please, 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 I think that students do not emphasize what is on your screen right now enough. Side-side angle and angle, angle, angle are never, ever, ever, 100% never, ever, ever going to prove triangle congruency, ever. So, again, we proved why through these diagrams, through those rigid motions. So go ahead and ask yourself, do you feel confident in understanding what side, side, side looks like?
I hope you're in the green.
Do you feel confident in what side, angle, side looks like?
Again, hoping you're in that green.
And do you feel confident with what angle, 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 or no, I'm sorry, angle, 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 side, angle looks like? I swear I could say these letters. And lastly, do you feel confident in your ability to talk about angle, angle, side? And what cannot be used ever? Those are those angle, 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 and our angle, side, side, or side, side, angle criteria that never work for congruency.
And if you're not in the green on any of these, please, please, please send us a message.
Reach out to us, reach out to your teacher as soon as possible to make sure you are confident in what you're doing.
Absolutely. Hey, Mrs. Michael.
Hey, what, Miss Nat?
What did the triangle say to the circle?
I don't know what.
You're pointless.
Thanks for joining us in 3.3. We will talk to you in
3.4.
3.4.